Okay. Uh, so I am Roman Liutikov. I am JavaScript developer. I live in Chernihiv, blah, blah, blah. And my speech is going to be about React Native and in particular my experience with React Native. We had a project with this platform, so I decided to tell you how it feels to use it. And I want to tell you why some of speakers are talking in English today, because we think that Ukrainian community is isolated from western part of Europe, from America, and everything else. Why we are isolated? Because we are talking in Russian and in Ukrainian, and nobody understands us. So that's why we should try to be closer to them. So next, we can do a big conference, and we can get more speakers from any company we want, because they will see that we are talking in English, what we are talking about, so we are cool, so they are fine to go there. They will be not afraid of us. That's why we should try to do it. Okay, so also, check out my very cool t-shirt. That's me. My girlfriend made it for me, and I said that I'm going to show it to everyone on every conference because I love her. Can you please make some applause for her? Thank you very much. Okay, so React Native. As you know, there are a couple of ways to do native applications. We have web view-based applications. It's basically a wrapper around your website. It's PhoneGap or Cordova or something else. So if you don't want to build truly native application, but you want to reach to users who use only native applications, you can wrap your website, ship it, done. Cheap, fast, and slow. And also, there are a couple of solutions for truly native UI built with JavaScript. Not only native script and React Native, but there is also TabResJS, and I guess a couple more solutions. But most popular are native script with Angular 2 and React Native. The previous speech was native script. And this one is about React Native, so after this you can decide what's better for you. You can decide what to use if you want. So yeah, and these slides are made in style of Suicide Squad. Very great movie. Have you seen Suicide Squad? Yeah, not very good movie, yeah? Everyone expected more. Okay, so React Native was released in 2015. It's open source. It's maintained by Facebook and community. And it's almost cross-platform mobile development for iOS, Android, and universal Windows platform, and also for desktop, I think, macOS. Yeah, and for Windows also, because it's UWP. It's based on React, so if you know React, you can read the code and everything because it's components, and JSX, all that stuff. Yeah, and React Native has new releases every 2 weeks. So that's somewhat good and somewhat bad part, because every 5 or 4 releases they have breaking changes, which will force you to spend a lot of time to fix all the bugs. So you should consider this. Yeah, so what's the benefits for developers of using React Native? You still use your language, JavaScript, because we are all JavaScript developers. And if you know React, you still use that paradigm, that framework, that library, that components, everything that you already know. Yeah, and you can develop cross-platform applications. Also, as I said, not 100% cross-platform. And interactive development, if you are working with React on web, you know hot reloading, right? When you can reload components on the fly, you don't need to restart everything. So the same applies to React Native. You don't need to restart your application. you hit save, it's automatically pushed to your application, everything is changed. But it's only true, it is only true for JavaScript code, not for native code. Because if you change something in native code, you should recompile it. That's obvious. Yeah, and also instant updates to your end users. You don't need to submit application to App Store. You don't need to wait. You can use service code push, which will take your JavaScript and push it to all of your users. So you don't need to, like, if you change some button or something, you don't need to wait 1 day till Apple will review your application. And yes, Apple allows you to download JavaScript in runtime, so they will not kick your application out of App Store. And I will mostly talk about iOS because my experience is mostly based on iOS development with React Native. But there is a guy somewhere who I believe worked a lot with Android. So if you want to ask something about Android development, you can find him. Yeah, raise your hand. Hello. Okay. Yeah. So React Native. What's the difference between Cordova application, for example, and React Native or native script application? The difference is that we are using native views. So we have JavaScript, which knows how to access native views. We have a binding to native platform. So that's why we can use all of these native views, and everything is fast, everything is smooth, blah, blah, blah. So how it works? There is that red dot. There is JavaScript. It's running in a separate thread. There is native. It's also running in a separate thread. So we have main thread, and we have JavaScript thread. And between those threads, we have a special thing called bridge. That's where all bindings happening. So when you call something from JavaScript, it goes to bridge, and bridge knows which native module to call. So this is how you have this connection. Also, there are special kind of threads called dispatch queues. So they are used for native modules which you install into your application. What's going on there? Okay. So there is one dispatch queue for layout calculation, which is called shadow queue. Layout calculation is basically when you change some like size or something in your component. The shadow queue dispatches actions like tasks to calculate that layout. And also there is dispatch queue per each native module which you install. And here is a link to React Native Architecture Review article. It's like you can read it and get more understanding of how it works internally. So basically we have main native thread, JavaScript thread, and dispatch queues. Yeah, how to start working with React Native. You should install React Native CLI, npm, blah, 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 blah. You should buy MacBook, you should install Xcode, buy iOS device, Apple Developer Program, which costs $100. Then you need to install Java Android SDK Android Device Simulator. So a lot of stuff. And you should have Chrome DevTools because it's possible to debug your application with Chrome DevTools. Only JavaScript code, not native. You have integrated development tools into React Native to debug layout, which is very helpful. It's somewhat similar to Chrome's DevTools inspect element. And there is that service, React Native Code Push. So that's deployment tool. Yeah, so it's native, it's completely native. It runs JavaScript in separate thread. So you don't have anything except JavaScript. No HTML, no CSS, no DOM APIs, no web APIs. You have nothing. What should we do? How we can work with it? So if you're familiar with JSX, this is JSX, but instead of HTML, instead of divs, spans, etc., we have those components which are called, for example, view, text input. Those are a small part of already provided components for you from React Native. So that's basically bindings to native views. View is binding to some view, text is binding to text string view, native view, text input, and so on. So that's how you can use it. And you attach events with special attributes, styles. I'm going to talk more about styles next. Yeah, so styles. There is no CSS, but there is still a kind of CSS, because CSS are like, we are all familiar with CSS, right? And we don't know any other way to style UI. So Facebook implemented a subset of CSS and subset of Flexbox, let's say. You should write your CSS in JavaScript. So instead of having that snake case, you write all the keys in a camel case. That's basically JavaScript CSS. This one, oops, sorry, next. Yeah, so stylesheet.create, you don't have to use it. You can just take that object, and usually you have this object of styles in the same file with your component. So you have files, you have UI with styles for this UI in a single file. Then you can use that styles object like this. Styles.text goes for text. Styles.textInput goes to text input. That's how you group it. But there is a special function called stylesheet.create, a special object with a function create. Why we should use it? Let's say if we are not using stylesheet.create, when component gets re-rendered, every time we will pass into native view that object with our styles. So that object should go from JavaScript through bridge to native. It means that we need to serialize it on every call to native. And if you have frequent re-renders, it will be slow. So that's why we should use stylesheet.create, which will compile that object into styles object, pass it to native, and then it will just assign styles by ID. It's just a number which corresponds to that compiled style on native thread. So that's optimization. Okay, styling gotchas. Yeah, use stylesheet create. A couple of versions ago, they implemented cross-platform Z index. Before there was not like cross-platform way to change order of layers, but they implemented that index, which is kind of cross-platform, because on iOS it works very weird. You cannot do, you cannot change order of views, of child views of separate components. Those components, those views should be on a same, like, structurally they should be neighbors, not in separate components. So it like limited that index, but at least it's cross-platform. Yeah. There is no cross-platform shadows. So for Android you use special rule elevation, which is kind of material design stuff where you can set the elevation above the surface of your screen, let's say, and you can set elevation 1, it will be like 1 point or something, it will drop a shadow which is realistic to that height. Yeah. And for iOS you should use special rules like shadow offset, shadow blur radius. Yeah. And dimensions. Dimensions also are a bit tricky. Dimensions are set in points, not pixels. I think iOS developers, like native developers, already know this, but web developers used to something like pixels. So in native we have points. Because why we have points? Because we have different screen resolutions. We have 2x screen, 3x screen, something else. So, and all of these like scales are based on some base resolution. For example, for iOS, base resolution, as far as I remember, it's 320 by 480 probably. So that's 1x. When we have 2x, it will be 2x in pixels, but in points, it's still the base resolution. So this is how we can achieve that. Like we can set only one size, horizontal, for example, 320 pixels, and it will be full width on any screen. So it's like ems or rems in web, flexible points. Yeah, and because of that, it seems like there is no way to set exactly 1 pixel width border, for example, because you set everything in points. If you set 1 and you have iPhone 6X, 6S Plus, for example, so it will be 3X. Your 1 point border will be actually 3 pixels, not 1 pixel. That's why there is a special constant in style sheet object, which is called hairline width. So it will, for every platform, it will be exactly size of 1 pixel in points. I don't know if it's, I don't think it's like predefined constant. I think it's calculated on compilation step. Yeah, events. So there is no click on change, on submit, and everything else that we have in web, and we cannot put those event handlers on any view that we want. So there is, if you want something to be responsive to interactions, there is a special component called touchable highlight, which you should wrap like any view that you want to be responsive. So it's basically, visually, it's nothing except that when you press something, it will change the opacity. So that's how you get that like native feel when you press a button. Yeah. Sometimes you want to be you want to make responsive some like other components which should not display any changes when you interact with them. So for that you should use special events like on start should set responder, and there are a couple more. So they works more or less like event capturing in DOM. On every view you can set that event handler, and when someone touches or interacts with that view, you can say that I want to be a responder. I want to respond to that view or to that action, not some, for example, touchable highlight which is inside of that view. Web APIs. So as I said, there are no web APIs, but there are some web APIs which is polyfilled, like native APIs, which are polyfilled especially for JavaScript developers. For example, geolocation API, it looks exactly the same as in JavaScript and works, I guess, also exactly the same. Except that, I don't know, maybe it's in browser, works the same way, but as a second argument, you can pass an object where you can specify if you want high accuracy coordinates. Yeah, there is request animation frame, and I guess also request idle callback gets implemented soon, and XML HTTP request and fetch API. There is no local storage. You should use async storage. Async storage, I don't know which native storage they use, but I think it's some like what we have already in platform. Yeah, next. Cross-platform React Native. How to build cross-platform applications, at least how to try to build them. Facebook said, learn once, write anywhere. So you should write for one platform, you should also write for another platform. That's a bit confusing, but there is like strong sense behind this. Why we should build separate, why we should write separate code, separate UI for different platforms? Because, for example, there is a difference between iOS and Android. There is a difference in UI conventions. As you see, that's, for example, iOS. We have tab bar here. It's marked as green. But on Android, it's here, and it's not tab bar. It's like something like tab bar, but when you click, it changes. I believe it slides like this. But on iOS, you don't usually slide between tabs. You just jump to that tab. So there are like differences. As I said, platform-specific components, different design guidelines. By the way, there are links to iOS and Android UI guides. So if you want to build like good application for users which are used to their platforms, because if you build iOS application and then you use exact same UI in Android applications, and you as a user will open this application and you already know some UI elements and how to interact with them. So you will expect that you will have the tab bar on top. I guess it's not a long time while you will just delete this application because you cannot like use it. You didn't use to this behaviors of applications on Android. So that's why we should build things differently. But still we can share some code. And the amount of code that we can share depends on how we build our applications. So what can be shared? We can share content UI. Content UI, it's any UI that is not platform specific. For example, on Facebook, this is content UI. This is just a news feed. Maybe if you want to have some special buttons for different platforms, yeah, then you will need to build separate components for those buttons. But in general, this is content UI that you can share. You can build them. You can build this UI with native, with predefined components, views, text, and everything. You don't need some special platform-specific components. So domain logic. Data flow, how you transform data, how you store it, and everything else could be shared. Data fetching, if you use fetch API or XML HTTP request, which is baked into React Native, you can already share this. So you can have web API module and like stores, Flux, Redux, blah, 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 which just data transformation and the way we use this data. If you build this decoupled from UI, you can share it. You can get like 100% sharing of your business logic, but not UI. And you can even share this with web application. If you, for example, build a web application, like support web application for your own mobile web application or vice versa. So you can use that logic also. Yeah. As I said, separate domain logic and data fetching from UI. Use anything for separating it, Flux, Redux, Relay. And try to use cross-platform native modules as much as possible, unless it's really meaningless. Because there are some native modules that doesn't do much, but and you can implement this in JavaScript. So if it's not heavy computations, you can do it in JavaScript. If it's not animations, like heavy animations, you can do it in JavaScript. But if you have heavy data processing, it's better to move it in a native module and maybe even work with it in separate thread. Yeah. So if you have platform-specific components, you can divide them by files. You can use special suffix iOS or Android, so it's name of the platform, and you can build here a component for iOS and here for Android. So when compilation will run, React Native CLI will understand automatically which file to grab based on this suffix. There is also a component called, not a component, but object called platform, which has two properties, iOS and Android. So if you need some cross-platform, a little bit of cross-platform logic in one module, for example, so you can use that platform.ios, if platform.ios do this, and if platform.android do this. But if you have a lot of logic, if you have different components, it's better to use them in separate files. Native modules. What are native modules and how to build them, how to use them? Examples of native modules are tab bar iOS, so that's that tab bar which is on the bottom, toolbar Android, that one that on top, view pager Android, I think that's like when you do this between pages. Do not use pure JavaScript module if there is a native one, yeah, because it's faster and it's already optimized for platform. Because there are really a lot of JavaScript implementations of different native features for React Native that work horribly. So if you want to use some of them, just read the code first. Try to use rnpm to install native modules. That's a package manager which you can install with another package manager. So first you need to install it with npm, or maybe in recent versions of React Native it's already baked into React Native. But basically what it does, it not only installs components, packages from npm. For example, if you want to install native module, you usually write npm install blah blah blah, but then you need to link all the libraries, all the native libraries inside of that package manually in Xcode, for example. But rnpm will do all of this for you. At least it will try. Yeah. Also, if there is something missing, you can search for it in platform already. Because if you want, for example, use checkbox, not a checkbox switch, you know, on iOS there is a switch with a green background. For example, if you see that there is no, like you cannot import from React Native that component, it doesn't mean that there is no this component, because you are using iOS, so this component is already baked into iOS. The only thing that you should do is to bridge that component to JavaScript. And actually, there are a lot of components that need to be passed into JavaScript. So how to do this? How to build native module? For example, that's Objective-C. That's for iOS. We create a file. I'm not very good Objective-C developer, so I don't know what kind of file it is. I don't remember the extension, but basically we create a file. We import RCT React bridge module, which is basically we are requiring bridge here. So we tell that use this bridge, and then we will pass through you some components to our outer world. So we declare interface, that will be our component calendar manager, and it should implement RCT bridge module, right? Then we create another file where we implement calendar manager, and we also implement that RCT bridge module. We use special function RCT export module, which tells that this module will be exported to JavaScript. And RCT export method to export methods. So you can export only some methods and leave other methods inside native. Here you specify the name of the method which will be accessible from JavaScript, arguments, and so on. After this, you should require a special component, a special object which is called native modules from React Native. And on compilation step, all native components will be assigned to that object. So after this, you can grab your calendar manager from native modules, and you will have that add event method, which you specified here. So that's how you bridge them. There is more work required when you have some native modules written in Swift, because you should first take Swift, bridge it to Objective-C, and then bridge that Objective-C to JavaScript. Okay, performance. That's the very first performance bug that I encountered in our application. So if you have some images which are like this, and you want to display that image like this, don't scale it at runtime. Just scale it or ask your designer to build like really small with exactly the same size which you need. Because if you scale it at runtime, at least scroll will perform horribly. It will like So don't do it. Use SVG if possible. There are a couple of SVG solutions for React Native. One library which is called React Native Art, which is already in React Native, but there is no documentation for this. And you cannot find anywhere like that there is something like React SVG in React Native, but somewhere deep inside of GitHub issues you can find that there is such a package inside of React Native. Yeah, one problem with this that you cannot use easily compound SVG graphics. For example, when you have one pass and another pass, and that's one single SVG file, you cannot render it because every single React Native Art SVG component is a component which displays only one pass. So you will have to take those two passes, create two components, and then compose them manually. You cannot just render a couple of passes together. So there are still some work required. Yeah, some very frequently the bug that you will frequently get is ListView Performance. So ListView is a special component for displaying lists, and sometimes when you have a very long list of components, and every item that component is more or less complex, have more or less complex layout, you can see some like lag. It will be not perfectly smooth. So there are a couple of attributes, and I think they have even more of those attributes, which allows you to apply some let's say restrictions on how ListView should render. So initially render only 15 items, and like every render should render only 15 items. Data source, it's the source of items for UI. Render row, it's a function which should render a row, an item. Yeah. So sometimes doing infinite scroll lists helps to achieve more performance. But I think that it's already baked into ListView in the recent versions, because previously there was no ability to make infinite scroll in ListView. Okay, if you have frequent rendering of something, and on every render you set some styles to the component, and you have performance penalties, you can use special method which is available on all components, which is called setNativeProps. What it does is that instead of setting properties on JavaScript React component which wraps native component, you set those properties directly on native component, on native view. So what it means, why don't we then use setNativeProps every time? We use API which we were given by React component which wraps native view, because then we can make controlled changes. You know, like controlled input, it has state inside of it, or we define a state and then we control how value behaves, how we set value, maybe we do some validation. So it means make something to be controlled. And if we use setNativeProps, it means that we are avoiding that like control state of component. So we set it basically on native. We don't have any control on it. We cannot get back that value. So yeah, if you need to change very frequently something, try to use setNativeProps. Try to avoid expensive work during animations. It means, like, for example, when you animate something, or not only animations, by the way, but only interactions, also interactions, like swipes, everything else. So if you have, for example, animation of changing screens, like you press a button and another screen goes, another view goes into screen, basically a new route. And for example, if you have a network request, Because when you click a button, you want a new view with some data which is going to be requested from the server right after you press that button. If that network request will finish much sooner that the new screen will finish like its animation into screen, you will probably get a lag in this animation because you will get new data, component will render, and that animation will lag. I think there is an example, yeah. So this is one expensive computation in component did mount. You see, press, and there is some computation with timeout. For example, the usual transition takes like, I don't know, maybe 300 milliseconds. For example, here we have timeout in component did mount 15 milliseconds, and after that I do like while loop. So this is that lag. But if you use special module called interaction manager, you can delay execution of that slow code, but you still can have your code in the exact same place. You don't need to move it somewhere. So use component called interaction manager and method run after interactions. Basically, you specify here a callback and then your code. This helps, for example, in this case. Or in some cases when you have drop-down with some input, for example, filtering, search filtering or something, you hit OK, you do network request, and when you hit OK, the drop-down should go up. In that case, you can also have animation lag. So, animations. There are also different ways to do animations, but they are not different in that sense that you can do the same thing in different ways. First one is layout animation. Layout animation should be used to do uncontrolled animations. It's like the same, let's say it's the same as set native props. So basically you spin up some animation and then you cannot control it. Native thread will take care of it and finish this animation. How it works? So there is an object layout animation which allows you to configure next animation. And here we pass some config. Config is basically an object with some properties, with some configuration for that animation. For example, how I want to interpolate numbers, which easing I want to apply to animation, blah, blah, blah. So what it does is that it configures next animation, but that animation is not like, we didn't specify to which UI element we want to apply this animation, right? So how it works, when we change some position of any element on a screen, even if it's a couple of elements, after we configure it next animation, React Native will animate those changes. So for example, here we just change position. We update position when here the button is clicked. So we update position of that block and that block. But if we configure next, if we use layout animation, we can set up it in component will update. So we click here, those component gets new styles, and those styles properties will be interpolated and everything will be animated. But you cannot cancel this animation because it happens entirely on the native thread. But also it means that those animations are very performant because you don't need to control them from JavaScript. You don't need to go through bridge. Okay. Animations, animated module. Animated is used for controlled animations. So you can build some like timeline animations, you can chain animations, you can specify, I believe there are special methods for doing spring animations. So you create a value with new animated.value, custom value. Usually you set it into state of the component, and then you take that opacity from state and pass it into styles. And then anywhere, for example, in your event handler or in some lifecycle method, you can call animated timing, pass reference to opacity, and say that I want to animate this value, to interpolate this value to value 1. So it basically doesn't animate. They think it just interpolates from 0 to 1. But then you use special component animated view. Basically, it means view component from animated module, which accepts that animated value, because it's not just a number, it's an object which has this interpolated value, but it has also some special metadata for, like, probably some native stuff which optimize this process, this animation. So with this, with animated, you can intercept animations, you can cancel them, and anything else. So, and they, animated animations, they became more or less, I would say, even more like they have good performance, because recently they started to move controlled animations to native thread. Somehow, because of like declarative nature of animated, they achieved that like compilation of the entire configuration of this animation, even if you can control it, and move it into like one batch to native thread. So like hard engineering, but it works very good. Maybe a couple of releases before it, you could still see some lags, but right now it's fine. Yeah, so animated, use it for controlled animations. They're animated animations controlled from GS thread, and they also have imperative API. It means that you should call it's like this, and because of that imperative API, it means that you should use lifecycle methods to call those methods. For example, if you know a library called React Motion, they have like declarative API which fits into a React rendering model. You have special components which describe it in JSX, so you don't need to use any lifecycle methods to use those animations. And a lot of React Native components has imperative API, but it's very easy to build a declarative component around this imperative stuff. You can just wrap it with React component, and for example, if you take a share component, you know, when you press a button and you have a share pop up and you can share to Twitter or somewhere else, it also has imperative API, but you can wrap it easily with JavaScript, with React component. And you can pass some props, and based on these props, you can run in lifecycle method of that wrapper the share methods. So you will have something that fits into rendering model, and you can use it very easily. Yeah. Navigation. Navigation is interesting because it is different from how we build navigation in on the web. On web, we usually, like, not usually, every time. On web, we have URLs. This means that we, our, let's say, routing map seems like a tree. We have slash, root, then we have, for example, admin, then under admin we have user, blah, blah, blah. So basically it's a tree of routes. But on native, usually it's just stacks. For example, I don't know if I go back. No, it's too far. Okay. So this is a screen, and we have, let's say it's iOS application. We have a tab bar, and we have those tab buttons. Yeah. So when we click on some tab, we go to another screen, and this screen has like it is a part of a stack of screens which are related to this tab. So if we go to another tab, it will have related screens to this tab. So that's basically how it's like the usual way how you structure navigation in the native applications. So you don't have any trees. Like maybe it's like a tree. You have some main and those branches, but you just have these stacks. So what Navigator does, special component called Navigator, it only maintains that stack of rows. It's array of objects, and every object in that array is like description for some road. For example, you can put in that object component which you want to render for this road. You can put a title, you can put anything else. So Navigator does maintenance of that stack and provides useful methods like pop, which means go back, push, which means go forward, and a couple more. And also Navigator does animations between screens. So if you don't need animations between screens, you don't have to use Navigator, because you can build a very simple React component which will maintain that stack. And you can also build like wrapper on top of Navigator, which gives you even more like useful, I don't know, navigation, for example, management methods. Yeah, so no nested roads. Navigator maintains only a stack of roads, not a tree. It runs transition animations between screens. It also has imperative API, but it's very easy to make it somewhat similar to, for example, React Router. You can build those link components. You can build something that you are already familiar with. But this is an old thing. Not very old, but there is a little bit more interesting stuff, which is called navigation experimental. This is relatively new component for navigation, and it uses some stuff from Redux. It not uses Redux, but for managing the state of that Navigator, they use reducer. So that's like a function which changes the state of Navigator. And state of a Navigator is an object where you declare all tabs, and you declare all stacks of roads for every tab. And with this Navigator, you can do complex navigations. You can have like tabs inside of tabs, routes inside of tabs, inside of routes, blah blah blah. So you can have a big object which represents the whole state of navigation, and you can change it with the reducer which you pass into Navigator. Navigation experimental. A lot of navigators for React Native are built with navigation experimental. Some of them, the most popular one, I guess, is React Native Navigator Flux, something like that. Okay, I have 10 minutes. Yeah. One suggestion: when you start a new project, think about how you would implement navigation, because your like structure of application, the way you build your application, the way you structure and layouts and everything depends on how you want to navigate between views. For example, there might be a case when you want to navigate to a specific view in another tab from a specific view in another tab. So you should think about it when you use when you are going to use some solution for navigation. Security, interesting stuff. Is it secure? So as you may know, it's very easy to unpack every native application. I will not tell you how, but you can Google for it. Okay. And disappointment. JS bundle is stored as a plain text. And it's not very, it's not minified very good. So you can read it. You can just unpack application and read the whole code. You can find out if there are redux, relay, all the actions, how they fetch stuff, and everything else. So is it secure? Well, everything can be hacked. You can disassemble iOS application and blah, blah, blah. But previously, before React Native, we didn't have any chance as JavaScript developers to get inside of native applications, because we don't know how to unpack, how to disassemble all of that code, how to read it. But right now, everyone can unpack this application and can read your code. So think about it when you start building like application with React Native or any other technology which is similar to this. One possible solution which I can think of is you can apply some like cryptographic algorithm to that bundle, and you can store the key inside of the native code. So for JavaScript developers, it will be almost impossible to get source code because we don't know how to read that native code. And this key to unpack the bundle will be like isolated from us. So this is how you can try to prevent this. How to develop applications, like some tools, useful services. There is a thing called React Native Playground, rnplay.org. So that's basically something like JSBin, but you have also here iOS device or Android device. Those are real devices, or I don't know, maybe simulators, but they are running on like real computers in some data center or something like that. So you can prototype here, you can save those bins, you can send them to your designer so they can check if everything is okay, or maybe you can prototype some new idea. But if you don't check this bin like for one day, it will be deleted because they cannot maintain for everyone those things. But you can still do it, yeah. So yeah, remember that application runs slower in development mode because a lot of debug is running in development mode, debug stuff. So it will run slower. If you want to show it to someone, like, look, JavaScript can be fast, first compile it in production mode. Don't forget to enable hot reloading because it's disabled by default. You can debug in Chrome DevTools, you can debug your JavaScript code, but you cannot intercept network requests, I believe. You cannot see network requests in Chrome DevTools. Yeah, and use integrated inspector to find components, inspect styles and layout, because it's very useful. That's how it looks. You can call a special menu with Command D or Control D, or you can shake your device. It will show up. Here you can enable hot reloading. You can show perf monitor. It's like some graphs, some information about rendering. You can hit show inspector and you will get this inspector. You can hit inspect, then select element, and it seems pretty much like Chrome DevTools. It highlights padding, highlights content. You can see here margin, padding. You can see structurally how deep inside of the components and inside of which components your component. You can see styles. You can see the line and the file where this component is declared. You can click on that black box and it will automatically open your editor on that file, on that line, so you can edit that component. And you can also see touchables. If you can see this, those components are surrounded by some like green fields. So these are touchable areas. It's very useful when you need to make sure that your UI, like buttons or anything else, is like fine for pressing. Yeah, like you can hit it. It's not too small. For example, it's not 10 by 10 pixels. So you can debug touchables. You can make sure that they are comfortable to press, the exact size. And you can also change the size of those touchables with special attributes. Tests. If you separate logic from UI, you can do usual unit tests, like with Mocha in Node, because it's just JavaScript. If you want to test components, you can use Enzyme. They have more or less fine support for React Native. with Mocha or anything else, so we can like create shallow copies, shallow renders of React components, and you can test properties and everything else. But if you want integration tests, you need somehow to run those applications. There are a couple of resources, but I think the most popular one is Appium. I think they have exclusive support for React Native. I mean, the best support. Yeah, and for deployment, use React Native code push to deliver JavaScript and assets updates. Yeah, it's not only code, it's also assets. So you can push images, some other files. I think it works with JSON, maybe sound. I don't know. Maybe it should have some restrictions, but for sure you can push SVGs, PNGs, and JPEGs. So are we there yet? Is it like the best solution? I mean, not only React Native, but similar stuff. Okay. In general, I think it's still better than hybrid apps. As for React Native, it's in active development. It means that they change in a lot every week or two. The documentation recently became very, very good. You can read a lot of stuff there, a lot of stuff for native modules, for every component, for optimizations. You can debug. You can learn about debug, advanced techniques. Yeah, quality of modules made by community is somewhat questionable. It's not like very good, but you can still find good components. Yeah, there are a lot of issues, lots of small issues which are very annoying, and they not trying to fix them very fast. They are more like focused on more global stuff, how to say the world, and everything else. Yeah, you can go there. You can Google React Native Showcase. You can see a lot of applications that are built with React Native. For example, SoundCloud application, Facebook Messenger, I guess it's half built with React Native, because by the way, you can also integrate React Native in your existing native application. Yeah, when you should use React Native, or why you should use React Native. As it was said by previous speaker, if you don't have native application developers, but you need that application, and you have JavaScript developers, it might be a good idea to just teach them, to give them some time to learn. So, yeah, it's a cheap way to make good native applications. Maybe you cannot build very advanced application, but at least an application with even more or less complex animations, you can still build it with React Native. Future, there should be some IDE, because in Xcode you can like change layout like in Photoshop, you know, like you can change padding, blah blah blah. But in React Native you should do everything with code. So there is something which is called Deco IDE, and they pretend to do it, and it's more or less fine. So there is already some UI to work with components, so you don't need to change styles in code. Isolated UI development, React Storybook, React Cosmos, React blah blah blah. There are a lot of already tools for developing UI components in isolation of your application. It allows you to build components which are truly isolated and truly reusable. So better performance. Performance is never enough. More platforms support. And we, as JavaScript developers, we should learn from native mobile development, that's for sure, because there are already a lot of techniques used by native mobile developers which are used to this platform, which like a standard. But for example, me as a JavaScript developer, when I started doing this application, I started applying some techniques from web to do some like layout stuff. But that's not right. We should use from native developers how to do the stuff right, how they are doing it for ages. So here is a list of links, reading, looking, blah, blah, blah. That's all. Thank you very much.